Amari, and I'm going to start the pre-lab discussions for experiment 1 of organic chemistry lab, which is about measuring melting point and everything about melting point, all theoretical aspects and practical aspects of the measuring melting point. The purpose for this pre-lab discussion is to prepare you to take the pre-lab quiz, but I want to just let you know now that the pre-lab discussions that we have here is not going to be enough for you to take the pre-lab quiz, but it will help you a lot to watch the pre-lab discussions and also read the experiment from the lab manual so you can answer those questions properly in the pre-lab for the pre-lab quiz. The questions are very detailed, so please pay attention to the pre-lab discussions and also review the experiment from the lab manual before you take the pre-lab quiz. Melting point of the organic molecules. So to measure the melting point, or the purpose for this experiment is to learn about practical and theoretical aspects involved in melting point or melting process, to determine effect of impurity on melting range, how to perform the experiment or measure the melting point, calibrate the thermometer, and the use of mixed melting. Thermometers must be calibrated, and because not every thermometer measures the temperature exactly and accurately, so they need to be calibrated. How do we calibrate the thermometer? Is we are using standards, pure substances that they are available in the lab, and we know the melting point of those compounds already. When we measure the melting point with the setting in the lab, and if the melting point is 2 degrees, it's recorded at 2 degrees less than the literature value, and since the substance that we are using is expected to be pure, so we can use that 2 degrees as the calibration for thermometer in that temperature range. Factors that affect the melting point, one is the size and the shape of the molecule, and then the intermolecular forces. The stronger the intermolecular force, the higher the melting point. The purpose of measuring the melting point, or what are the application in the lab? One, we can identify a compound by using the melting point and comparing the measured melting point in the lab to literature value, especially if tables of the possible compounds is provided with the melting point. We can do that easily. And sample purity. How do we know a sample is pure? By behavior of the melting point. If the sample melts with the sharp range of melting, then the sample is pure. Impure samples, or the samples that they have a low percentage of impurity, they are going to have broad range of melting. That cutoff is like 2 degrees. So if the sample starts melting at 100 and let's say 19 and stops melting at 121, so that's a 2 degree, about 2 degree range of the melting. That means we have a pure sample. So if the sample is not pure, it can start from at 105 and stops melting at 118. So when we have like 15 degree difference in between the initial melting and the final melting, this sample cannot be pure. So we can determine the purity and we can determine the identity of the compound using melting point. If impurities are present in the compound, how it's going to affect the melting point. Impurities, first of all, would lower the melting point. So if this, for the pure compound, let's say we have a compound that melts around 120, average of 120, if it's impure, it will start melting at the lower temperature. So melting is depressed, and is also the range is going to be broad. If you have insoluble impurities, because most organic compounds, they are soluble in one another, but if you have insoluble impurities like glass or sand, is not going to affect the melting point or the range of the melting. They basically is not going to melt, so your sample is going to melt. The melting point, it's always lowered by impurity. You cannot like increase it unless very high percentage of the impure sample with high melting point is present. 10% urea is going to lower the melting point from benzoic acid. If benzoic acid melts at 120, now impure sample would start melting at 110. But if you have a compound that melts at 150 and you get 75% of that impure sample, then it would lower from the 155, not from the 120. So if you have high percentage of high melting point impurity, the melting point is going to be elevated, which is like very rare that for that to happen. If we have mixed melting, how does mixed melting is going to affect or is going to help us? The mixed melting, we can confirm the identity of the sample. How does it work? The mixed melting is going to work this way. So you start with measuring the melting point of the sample. Let's say you find the sample to melt at 134 to 135. Then the possible, that compound, it could be one of these three possible given chemicals in a part of like larger table. Of course, these are not the only chemicals that would be provided, but you find out that it could be urea with 134 or benzoin with 135 or phenacetin with the 135. Now, you're going to mix your sample, your unknown sample, with urea, with benzoin, and with the third compound, and measure the melting point again. If your compound is identical to one of these three, the melting point is going to stay or would be maintained. But if the melting point is depressed, that means what you're adding acts as impurity to your unknown 2. For example, if your unknown 2 plus urea, if your unknown melted at 134, but when you mix it with urea, it depressed to 120, that means that urea acted as impurity, so your compound is not urea. So that's how mixed melting can help you. I also wanted to talk about the chart that is helping you for setting on the meltdown apparatus. What setting should you use? It is important for the sample to melt slowly, especially at the time or very close to the melting point. A fast heating is not going to give us accurate melting temperature because thermometer doesn't have enough time to record that temperature. So it's said that thermometer is lagging the temperature. So you can heat up the sample fast to begin with, but when it's getting close to the melting point of the sample, you have to slow down. How this chart is going to help us for the setting. Let's say we have a sample that is going to melt between 100 and 150. If the sample is melting between 100 and 150, the setting of the power regulator on the machine, on the meltdown apparatus, it should be set between 4 and 5. So if it's set between 4 and 5, it's going to heat up fast, but by the time it gets close to the melting point of the sample, it would reach a plateau. That means it's going to melt slowly. This is like about 2 degrees per minute, and that is going to be slow heating for best numbers or most accurate melting temperature recording of the temperature. So the good thing, this chart comes with the machine that we are using, at least in my lab. So I use this chart. If the sample is melting between 300 and 350, I'm going to set the machine around 8, because if I put at 2, it's not going to reach that temperature. So I'm putting between like around 8. Is going to start heating up fast. By the time it gets to the melting point of the sample, it would reach the plateau and it would be slow heating. So that's the purpose of using this chart. When you use the sample for melting point, you are going to discard that sample in the capillary tube. You cannot reuse the sample, because if you reuse the sample, it can decompose. Sometimes the organic compounds at high temperature, they would decompose. So when it solidifies again, it's going to be different compound. Or other times, when the sample it's changing to liquid and then it's going to crystallize again, it can form a different crystal structure, and different crystal structure is going to have different melting point, so we cannot reuse the sample. We also sometimes see that there's like unusual melting behavior for the samples. Like if the sample has like molecules of water, or sample is hydrated, is going to lose the water of water molecules of the hydration, and then it would give like a secondary melting, or it would melt at lower than usual. Decomposition often is associated with release of gas, so you would see that the gas is evolved, or you see the gas coming out, the sample starts like melting, and then it changes back to solid, and it goes back to liquid again at higher temperature. So if it changes to liquid, so it melts, and then you see the gas coming out, and then it goes back to solid, means that that compound has decomposed, like a small molecule of gas has been released, and then the rest of the molecule has changed to a more stable with higher melting point of the compound, and you have to heat up again. So decomposition has taken place, so you can include that in your part of the observation. So when you watch these pre-lab discussions, read the experiment from the lab manual as well, take the pre-lab quiz, then you are going to watch the actual video while I'm performing the experiment, and you collect the data and you record those data, and you're in a piece of paper in your lab notebook, so you can use that to write your lab report. So this experiment is going to have multiple sections, and then you will gather the data, you will collect data for multiple parts.